Hey guys, welcome to the Sub 6 PTP planning session. My name is Sagar Deshpande. I'm the product manager for Sub 6 Point to Point. For today's agenda, we'll be going over some of the best practices, focusing a little bit on link planner, link alignment, low MCS rates, and how it can be really useful to align links. Also, we're going to be focusing on point-to-point portfolio to kind of understand what our product portfolio is and how it best fits based on your needs. After that, I'll be providing some helpful tips and information. As always, post your questions online. I will get to them towards the end, so feel free to fill them up. And once I'm done with the presentation, typically these kind of webinars, especially point-to-point link planning, tend to be more of a question-answer driven session. So let's get started. Sorry. Okay, the first step that you need to think about, especially with respect to link planning, is know your requirements. By what I mean by know your requirements is you need to know which spectrum band you're already going to use. Are you going to use a 900 megahertz channel? Are you going to use a 5 gigahertz? Are you going to use a unlicensed, licensed 3 gigahertz solution? Depending on the type of use, each frequency has its upsides and downsides. So unlicensed products can be cheap, but depending on your location, there might be a lot of interference built in as part of that one. The next part which you need to think about is what kind of realistic throughput are you requiring on each link. This can typically mean, like, not only for today, what kind of expectation do you have this link capacity to do in let's say 6 months, a year, 2 years? Because especially with point-to-point links, you want to keep them built and then you keep them there for a really long time, probably around 6 to 7 years before you start to replace them. So you really need to think about what kind of link throughput do you need to have, especially on your main backhaul link or even towards your edge point-to-point node. What kind of throughput requirements are you going to get? You also have to think what kind of demand plan you're going to, how many more subscribers are you going to get in the next 6 to 8 months or up to 2 years. Next, this kind of piggybacks on the last question is what kind of backhaul capacity do you need? So this backhaul is probably going to be your node which starts from your server. So typically, depending on the subscribers, you need to realistically think is like my worst case scenario, how much or most usage, worst case scenario, how many customers are actually logged in and how many people are going to draw the how much throughput, especially towards the evening of the day, especially if you're using it for a residential deployment. Next, you need to think about what kind of topology are you going to do. Are you going to focus? The two main types are ring topology and tree topology. Ring topology typically has redundancy built in. So which means if a radio or one link goes down, the ring can be the overall link is not broken because you can always change the routing session to go the other way. These are a little bit more expensive because you need to add a few redundant nodes, whereas tree topology is really straightforward, but you need to think about contingency or redundancy, especially if one of the radios goes down, either through interference or through lightning strikes or any other reason. You need to think about that because if your main backhaul goes down in a tree topology, it becomes really hard to bring it up it becomes really tough for you to bring it up quickly, especially if you're deployed in like a remote location. Next, you need to think about is licensed and unlicensed. There are some benefits of licensed and there are some benefits of unlicensed. Licensed benefit is there's no one to bother you. If you buy a 6, 11, 18, whatever gigahertz license, which is 50 megahertz or 100 megahertz, whatever it is, you might be able, that link is yours. So you can go all out on speed, and knowing that no one is going to bother you, and you can have a steady expected throughput. Granted, the licensed products are a little bit more expensive than the unlicensed, but if you want to have the capability or the stability of a strong backhaul link, a lot of vendors prefer going the licensed route, especially for their core backhaul solution, and then depending on the network or location, they might think about unlicensed or licensed towards the edge of their point-to-point. Unlicensed is really good. It's really good, especially if you're getting started, or especially if you're in rural areas where you know you're not going to get much of interference in either way. So that would be one of the advantages. Next, you need to also think about link availability, which is 5 nines and 4 nines. So what I mean by that is the table which is listed below. So basically, link availability is what percentage of the link is available throughout its duration. For example, if you have 95% of a link available, it means your link is down pretty much 18 and a half days in a year, which is about 1.2 hours a day, which is not acceptable for a lot of conditions. So if you're at 2 nines or 4 nines, so then you start to get to the commercial or or maybe residential link availability where your link is down maybe about 8 to 10 seconds or between 10 to 14 minutes. So this is 2 nines or 4 nines. If you're more of a commercial where people expect are doing business and they cannot afford to lose link connectivity, then you have to plan for a 5 9 or maybe a 4 9, which is typically within a few seconds in a day. But if you're going more utility-based, electricity, mining, or any other function which requires continuous throughput, especially for monitoring, especially for oil measurements and stuff like that, so you definitely need to plan at least 5 nines, if not more. These links. So as link availability becomes higher and higher, you have to start thinking about what kind of products do you want to use to get achieve what. So 2 nines, you can think of it's easier to align a 2 9, but for a 5 9 or a 6 9, you need to have a lot of maybe they need to be shorter so that even if there's interference, or maybe you need to have different routing mechanisms. But typically, you have to think about link availability as part of your project or as part of your solution as an overall global picture. Next, you need to focus in on location. This is a snapshot of Link Planner. It has a feature for American towers. It kind of lists out, especially in the US where American towers are. You can use that capability. But the idea being that you always want to fix the right location where you want to deploy, because typically once you fix it, it's going to be there for some time, typically a few years. So you want to see multiple locations. You want to scout out the right spots. You want to scout out where other towers are. You need to scout out a lot of information. This really helps also to kind of think about from a big picture, saying like, hey, which towers am I already in? Which towers do I want to reuse? Which towers should I build my own towers? So based on your location and geography, a lot of planning before saves you a lot of time in the future. So I highly encourage you to kind of focus in, see the geography of where you are, what kind of solution might work for you, maybe on top of a mountain or between a flat plain or behind a forest. It depends on what kind of connectivity you're looking for. But the idea being that you need to pay a lot more attention to location than the general, because once you have deployed your radios, it has to be more fruitful than placing it in some location. Next, this is an important concept, which is plan your most difficult link first. So what is most difficult link mean? Typically, it depends on each scenario. So the idea for this webinar is more of a generic tone. So your most difficult link could be your non-line of sight, which is probably maybe 1 to 2 kilometers, a couple of miles away. It could be a near line of sight, which is like you have a rough patch, and you want to get across, but but that's your weakest link in your entire. It could be a longest link, especially if you're connecting to islands on over a water body. That could be your longest link, or that could also be the highest availability link. Is probably going to be your backhaul, where you want to guarantee some sort of link availability. So planning accordingly to that is really important. High throughput link, this is probably your end backhaul, which is going to collect all your subscribers' data, and high reliability link. So this could be one of those between two towers which are prone to a lot of interference, right? So each link, each project, you might be aware, has its own challenges, but you need to think, or you need to plan your links around your most difficult links first, because once you have those in place, the remaining becomes easier, right? So this again piggybacks on the location idea, being that once you get the location right, or you plan for your most difficult link first, then it becomes easier for you to plan the rest of the link out, because you've done the hard work upfront. You don't have to think about that. Next, and one of the most important concepts you need to think about is, where is the noise coming from? So first thing which I would highly encourage everybody is take pictures from tower sites, especially if you're on the top, which will help you identify the interference sources, right? So maybe you have a tower 20 degrees east, and then you have another one exactly opposite. So you know there might be some sort of interference coming your way if you kind of point it. So you have to be aware of what kind of uh, sources or interference you're coming. Typically, if possible, you can take your spectrum analyzer up the tower and kind of measure seeing like from different angles what throughputs or what kind of interference you're already expecting. That will help you a lot, especially down the line when you know, hey, if there's a new tower being built, you know you might get some sort of interference based on that. So you can try to avoid or try to mitigate it in different means. But taking a lot of pictures, especially from tower sites, because you can't go back. It also taking pictures also helps you tell the tower installers alignment issues. So you can show them pictures and show different landmarks, and it becomes much easier to align rather than looking for a spot really like a few miles away. It's really difficult. The last one is it's kind of tricky, but I think it comes through years of experiences, like having different tricks up your sleeve to mitigate them. So, for example, if you're using TDD sync, when should you use TDD sync, especially if you're co-located? Uh, when should you use high performance dishes, especially if you know you're in a really high noise environment and you're getting interference from other radios? So you want to use high performance dishes. You want to definitely use RF shielding. So RF shielding not only protects you from lightning, which is one of the things, the lightning protection, but RF shielding mainly protects you from interference from other radios. So as the Ethernet cable goes down, since it has copper, once if there's another wireless interference that happens, if it is not shielded, the data can get corrupted, and you might lose the information. So even though your radios between the two radios, the link might be strong because you have poor RF shielding. It could be that your data is corrupted and your overall link throughput is much lower than what you expect. All right. Next one is link alignment. I think this picture speaks 1,000 words. This kind of showcases why you would want to avoid a side lobe. The picture on the right showcases how any integrated or any antenna would have. So it has a main lobe and a couple of side lobes that kind of balance out. So depending on how you're aligning, it can take a few minutes to a few hours sometimes to get the alignment right. Uh, but the idea being once you get some sort of signal, you want to not only get to the local maxima, but you also want to search around a little bit more to kind of go horizontally and then vertically, almost like in a matrix kind of a way to kind of capture like, hey, am I on a side lobe or am I on the main lobe? This is a place where Link Planner also can come into effect. So Link Planner is our online tool which helps you plan different links. So on the link planner, it gives you a rough estimate on what RSSI level you're expected, give or take some percentage because of real world interference. But if you are off, you can definitely check with uh, the link planner tool to say like, hey, am I within range or am I completely off, or am I like a few dBs off? And then you kind of get an answer saying like, hey, am I on a side lobe or a main lobe? So I think thinking about it this way, especially with the alignment, it really helps out in the long run. So this is a really neat strategy. Some people are using. So definitely keep this in mind, especially when you're planning that once you get a signal doesn't mean that's on the main lobe. It could be on the side lobe as well. Next, I want to spend a few minutes talking about the portfolio at glance because I think this is really important because you need to know which product you need to use for which application, right? So towards on the slide you have on the screen you have towards the left you have bridge in a box, which is a post 200, which is typically like our DIY solutions like CCTV cameras in parking lots or any department store. You would just want to have some sort of connectivity across the street, across your parking lot, across your connect a few spots. So you want to use a bridge in the box. Towards the left or the rightmost in this case, we have the PTP 670, which is a carrier grade kind of solution, which is robust, has a lot of features built in. So you need to think about what kind of product fits your bill. I'll give you a quick rundown on what we feel based on the unique selling points mentioned, how each product fits in with our overall portfolio and why you would use one over the other. As I mentioned, Force 200 is bridge in a box, which is mainly used for our DIY kind of a solution. Then we have the Force 300, which is really good for setting up, which has a live spectrum analyzer which does 600 Mbps. So it is a connectorized. So today we only have an integrated version, but you can use two point to point and try to get about 600 Mbps. Typically, it's good for about 2 to 4 miles of range. Then the next we have the 450i PTP, which is based on the 450 platform. This also does about 200 Mbps. This is really good for narrow channel kind of, and it also has synced with the PMP 450. So that's really useful over there if you already have a PMP solution out there. Next, we have the PTP 450i. The advantages of this is it has a really strong dynamic interference filter, so that reduces your interference from other channels, co-channel interference. It also syncs with the PMP 450. So if you already have a strong PMP backhaul solutions and you just want to reuse the PTP 450i is a really good solution because it uses the same GUI. It's much easier to maintain. So it's kind of some of the accessories are you can reuse some of the accessories for each one of them, especially like power breaks and stuff like that. So it's really useful over there, and it also supports up to 300 Mbps. The next is our PTP 550. This is mainly built for speed. Typically, deployment is about 1 to 5 miles on average, but the radios can perform much longer distances, but you get much lower throughput. So typically, it's for 1 to 5. It's for short distance, backhaul, high throughput kind of thing. So you'd want to use this thing. So 550 has two radios built into it, so it's a dual carrier, and each radio can be configured differently. So you can have a 20 meg, 40 meg, 80 meg, or mix and match each one of them. We will have a feature called dynamic channel selection where the radio automatically moves if you get hit with interference, but that's similar to the DSO in the 670. The 670 is our one of our best products. This has been a product since some time. This is an evolution from the PTP 650. The 670 has an additional feature capability of high capacity multi-point. So basically, you can use it as few points. So you can connect up to eight nodes back to your main 670 for this reason. I'll keep this slide posted for you to kind of get a little bit more information out of it. But kind of understanding our product portfolio gives you a solution of, hey, if I want a high link reliability, which product would I use? Or if I just need to use one redundancy, what kind of radio do I need to use? And kind of it plays around. So all these are just the licensed spectrum. We also have the unlicensed, which I will not go through today. But I think this gives you a flavor of kind of starting like building blocks now, what things you need to think about, especially while planning your link beforehand itself. And definitely for more information, we would suggest that you visit our Cambium webpage, cambiumnetworks.com. Point to point, we always post out spec sheets, white papers, more information, product, more details. If there's a live deployment somewhere, we always have that. On our community, we also have a community forum, which is community.cambiumnetworks.com. We have different sections. One is the knowledge section, idea section. So a lot of people post questions, and then we help them solve. Especially some questions are related to alignment, some questions are related to configuration, some questions are related to best practices. But I think it's a nice place to come and share your knowledge and kind of understand, hey, if I am setting up link, what other issues do I run into? I just kind of highlighted two randomly from the 450. One question which was posted some time back was, how do you reduce jitter when establishing a link, and then how do you physically reset a 450? So all these kind of, it's a different set of, it kind of posts all different potential questions that you might have on each of the product bases. So to recap, on a high level, you need to understand what kind of requirements do you have, which means for each of the links, you need to know what kind of throughput you need to have, what kind of reliability do you need to have. Next is plan the locations beforehand, especially if you want to reuse the tower for multiple purposes. Third one is plan your most difficult link first. I think this gives you a really good advantage going forward because you have done the hard work upfront. And fourth one is check where the noise is coming from. Typically take a lot of pictures that will help you out in the long run. With this, I think that's all I have to present. I'm going to wait for a few minutes. If people want to post questions, I'm happy to answer them for you. So I'm going to stop speaking and just wait. select some of the questions that are in and then answer them. All right. So far, no questions in. I'm going to give it another minute. Feel free to ask any questions if you have. It could be related to the link planning or maybe something that you've experienced so far. We'd be happy to share it. So there's a question is which says, is the Force 300 compatible with the Force 200, or do I need to switch both of the radios? Yes, you would need to switch both of the radios because typically it's not compatible. You would want to use, if you have the APs, it's different, but if you're using 2SMs to connect, which you can, it's not directly compatible. You cannot use it. All right. I don't think we have any more questions. Thank you so much. I will be posting this webinar online or on community page. Feel free to check it out. And thank you. Bye.